This is the video for question 2. For this question, we know there are three functions. We need to prove or disprove whether this function can represent an autocorrelation function or a spectral density function. In order to solve this question, first we need to know some properties of the autocorrelation function and the spectral density function. The first one, for the autocorrelation function, because this is WSS process, so first it should be even, and then we need to know the Fourier transform of it must be non-negative. The third one is R tau smaller than R0. This is the three properties that must be met. The second one is for the spectral density function. We need to know there is only one condition. This is non-negative. So first, for the first function, this is the first function. It's easy for us to know fv equals to f minus v. So this is even. And second, we need to know the Fourier transform. The Fourier transform of this function is this. This one is easy for us to know. It's non-negative. Next, we know for this function, when v it increase, fv will decrease. So it's easy for us to know if this one is 1. So it meets the three conditions of autocorrelation function. So it should be autocorrelation function. And for the fourth one, for the spectral density function, it's easy for us to know this one is non-negative. So it can represent these two. For the second question, second function is this. For the first one, it's easy for us to know this function is even. And for the Fourier transform, after our computing, we can draw the figure of its Fourier transform, just like this. 2, 1. So it's easy for us to know this one is non-negative. For the third one, for this one, when v is, it's easy for us to know the fv is smaller than f0, and the result of f0 is 1. So it can represent autocorrelation. And for the spectral density function, we need to prove this one is non-negative. So it's easy for us to know this one is non-negative. So it may represent the the spectral density function. For the last one, this is the function of last one. So first we know it is even, and then for the Fourier transform of this function, it is because this one is not, this one can be negative, so the Fourier transform is not negative. So after finish this, we need to know for this one, it can't represent the autocorrelation, and we only need to prove whether it can represent the spectral density function. It's easy for us to know this one. If V is non-negative, so as a result, we can know it may represent the spectral density function.